Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farid bin MASRI. I'm from Faculty of Mechanical and Manufacturing Engineering Technology, Automotive Technology. So my entry number B0919103444 and my supervisor is Dr. ROSIDAH BINTI JAAFAR. I would like to present the Bachelor Degree Project 1. The title is the Performing New Material for Lower Control Arm Product Vehicle Using Finite Element Analysis Method. So the first chapter is introduction. The lower control arm is component of the vehicle that together with the steering knuckle is attached to the frame. Its primary function to maintain the vehicle stability by enabling the chassis and the wheels to move in concert with one another when the vehicle is in motion. The current lower control arm is now heading in the correct direction to the strength material that have developed, but there are still room for improvement in terms of the material strength so that it can produce more robust parts. It is much simpler to carry out an analysis of the lower control arm by making use the finite element approach. So the problem statement. There are a few different factors of the contribute to the deterioration of the lower control arm. The driver of a certain vehicle who's going too fast will be damaged the lower control arm. If this behavior is done over and over, the system will have to deal with the effects of the consequence. The damaged roads and uneven terrain. The lower control arm will become crooked, which could result in steering becoming unstable. Due to the fact the lower control arm was damaged, unable to steer so effectively, or that the wheel has a tilt either to right or left. We'll discover the alignment cannot perform adequately, may hear squeaking noises of clogs whenever the vehicle is traveling over road terrain or bumps in the road. Research objective. The number one objective for this project is to investigate the lower control arms materials and design with characteristic of lower control arm. Objective number 2, to analyze of lower control arm material static analysis using simulation. Objective 3, to compare existing product, new product of durability, lower control arm. Scope of research. Number 1, develop a comprehensive literature review of the lower control arm. Second, research of literature review. In this proceed to design the part using CAD software SolidWorks, the parameters involving measurement, material selection and color. Third, to come up with the result analysis for products with finite element analysis method using Alta Inspire. Fourth, comparison the lower control arm with two different materials to see the improvement from existing material product to new material product. So, chapter 2, literature review. There are 10 research that has similarity to this project. Number 1, title A Case Study on Durability Analysis of Automotive Lower Control Arm using Self-Transducer Approach. Findings on this article, load measurements are required to simulate vehicle durability when the vehicle is put through its paces. Second title is Analysis and Optimization of Lower Control Arm, Crimson Publisher. Finding on this article, a potential increase in tension may be experienced by the lower control arm, in addition to developments in technology. Third title is Design of the Lower Control Arm of an Electric SUV Front Suspension based on Multidisciplinary Optimization Technology. To carry out free model analysis, this construction is done using technology known as finite element. Number 4, design and analysis of lower control arm of suspension system. In this finding, a steering arm and L shape wishbone are commonly found on cars. 5 title is the composite control arm, analysis of the applicability in conventional suspension. The SolidWorks provide the opportunity to conduct independent analysis of the stresses and displacement experienced by each composite layer in addition to the overall structure. Number 6, experimental and finite element analysis of left side lower wishbone arm of independent suspension system. Finding on this article, the suspension arm is used in modern automobiles. It's made of mild steel, have the impact of the overall weight of the vehicle. Number 7, enhancing vibration reduction on lightweight lower control arm. On developing a novel lower density viscoelastic interface that can perform the function of both a damper and an adhesive at the same time. Number 8, generative design with solid thinking inspired. On this finding, solid thinking inspired could help engineers save both time and money. Number 9, the structural optimization of control arm for weight reduction and improved performance. On this finding, in order to evaluate how well the upgrade analysis performed in comparison to the basic run analysis, this design was created using topology optimization. So the last title is Engineering Finite Element Analysis. On these findings, few common examples can be solved using conventional methods. However, finite element analysis can solve any issue. So we move to the chapter 3, methodology. Can we see the overview flowchart? We start title, the discussion and confirmation for PS1. Number 2, writing a project proposal for the title and research on the design of lower control arm, and move to the research of material used on lower control arm. And we move to the project is working accordingly. If not, we back to the research on the material used on lower control arm. Then if yes, we go through the simulation and go to result analysis comparing. And the last part is conclusion and the project. So, proposed model design. We take example of lower control arm. It takes example of lower control arm dimension from the market. Then measuring lower control arm using vernier caliper and steel tape measure. It can be seen from the picture over the picture. This is the black one is lower control arm. Then to measure the lower control arm using vernier caliper and steel tape measure. Then after that, apply the design, sketch the lower control arm in SolidWorks. On the SolidWorks, make two different material lower control arm. Number 1, steel lower control arm, and the number 2 is steel carbon fiber lower control arm. For composite material carbon fiber, composite material, carbon fiber made as a core metal. Then combine with the steel part, then assembly like one can be seen at the example here. So we move to the simulation on Altair Inspire. So after the product design is done, so convert the files, move the files SolidWorks to the Altair Inspire to simulate the product result and analysis. On Inspire, before analysis the lower control arm, it must input load, support and load case. After the data inputs all be set, it can be analyzed the simulation. So the picture as the step of analyze. So the first one is run analysis. So move to the run history and run status. And the third, analysis result, and finally result overview. So in run analysis, set the large run submission dialog. So at the run history status will show on the run history from the history product. So move to the analysis result, show analysis result at a point of interest. At the analysis result also, he can compare the existing product and the new product to see the difference between it. And finally, result overview. On these things, it will display the result. So in this project, we want to see the displacement, safety factors, percent of yield, max shear stress, and von Mises stress. So after the analysis products done, it put the new material to the topology optimization to see the design space on the lower control arm. So so the flow process to the topology optimization. So the first is set design space, which is to create the most efficient distribution capable of. So move to the apply symmetry place to ensure the lower control arm is meshed symmetrically, and then apply support to make the lower control arm maintain in position when run simulation. Goes to the apply load to apply load on the lower control arm surface, and goes to the set optimization objective to toggle the lower control arm in maximize stiffness, and finally run simulation on this case to produce the result analysis of lower control arm on topologies optimization. So after the result analysis done, we go to the result data comparison. The information of displacement, factor safety, percent of yield, max shear stress, von Mises stress, and two products lower control arm are collected. The data will be compared on sample table below. So we can see this is a sample of table for two products, lower control arm, and their information. Expected result from this project to see that the new material lower control arm have improvement than existing lower control arm. Second, observe the result analysis in material lower control arm. Composite steel and carbon fiber lower control arm have better result than existing steel lower control arm. In topology optimization, the material in composite lower control arm structure able to withstand the forces applied on it, while cuts material away from design then creating lighter structure. That's all to my project presentation. Thank you.